Let me tell you how I got into this because I don't think my situation was unusual at all. I had built myself a command line tool that handed a fairly involved job over to an AI agent. And for the first 3 or 4 times I ran it, it was great. The output came back, I looked it over, I had a couple of small comments, and that was pretty much the end of it. But then the work got more complicated, the way work does. More steps, more moving parts, more places where somebody had to make a judgment call about what was right. And on top of all that, I kept changing the instructions myself because I was learning as I went along, and I kept adjusting what I was asking for. And somewhere in the middle of that, something started going wrong that I really did not see coming. The agent didn't get worse at making things. It got worse at telling the difference between a good result and a bad one. And these things are non-deterministic anyway, so I could run the exact same thing twice and get 2 different results back, which meant that on any given day, I genuinely did not know what I was going to get. So the output started coming back bad, and my day slowly turned into an argument with a language model. I would read what it had produced. I would write up everything that was wrong with it. It would go away and make the thing again. And then I would read the new version. And then I would do it again the next day. So what was actually missing there? Nothing in that pipeline was ever evaluating the quality of what the model produced. Not one step in the whole thing ever stopped and asked whether the thing it had just made was any good. Except for me, sitting at the end of it, doing all of it by hand. And that loop works perfectly well when there are 5 things to look at. But it falls apart the moment the AI starts doing the thing you hired it to do, which is to produce far more work than you could ever get through on your own. You wanted the leverage, and the price of the leverage is that you can't personally check the work anymore. So how do you fix that? You stop being the check and you write the check down. So a gate is a step whose only job is to decide. It sits between one step's output and the next step's input, and nothing gets past it until something has looked at that output and said yes. It asks the question, is this good? And it answers either pass or reject. And on a reject, it has to say why, because that reason is what feeds the fix. And then the whole thing runs again. Of course, nothing in life is perfect, so you cap that loop. In my case, it's 3 attempts, and after that it stops and tells me exactly what's wrong, because a loop that keeps retrying forever is really just a slower way of shipping something broken. And that gate, when I finally built it, turned out to be nothing more than the feedback I had been giving by hand, every single time, written down once. That's all an eval really is. It's a gate that you wrote down. Now the word eval trips people up, and I think that's because it sounds a lot like the word test. So let me separate 2 things that look alike but really aren't. A test asks a closed question. Did this function return 4? Did this endpoint give me a 200? There's a right answer, you know it before you run it, you assert it, and the machine tells you yes or no. Nothing about that is a matter of opinion. An eval asks a completely different kind of question. Is this summary faithful to the document? Is this explanation clear? Is this answer any good? And the truth is that there's no equals for any of that. Somebody has to look at the output and form an opinion about it. That's a judgment, not an assertion. And it's exactly why evals feel a bit slippery the first time you sit down to write one. You're reaching for a tool that measures correctness, and the thing in front of you is quality. The way I think about it now is this: a test protects your code, and an eval protects you from your AI. Let's go over what's actually inside one. And the good news is that there are only 3 parts to it. First, the cases. A case is one real input, together with what a good answer to it looks like. And the word real is doing a lot of work in that sentence, because what you want are actual inputs from actual use, and especially the ones that went wrong on you before. 10 of those is plenty to start with. Second, the run. You take every case, you hand it to the model, and you collect whatever comes back. It's a loop. There's nothing clever happening there at all. Third, the grader. This is the thing that looks at each answer, decides whether it passed, and tells you why. Sometimes that's plain code, sometimes it's a person, and sometimes it's another AI. And the way I approach this is to always start with the cheapest one available, because every problem that your free check catches is an expensive check you never have to run. Before we write any of it though, there are 2 things I want to tell you, because they will change how you read your own numbers. The first one is that a single run will lie to you. If you ask the same judge to grade the same answer twice, you'll often get 2 different verdicts back, with the same input, the same prompt, and the same model. That isn't a bug you can go and fix somewhere. That's simply what these things are. So I never ask just once. I ask 3 times and I take the vote. And if you're scoring on a scale, rather than a simple pass or fail, then run it several times and average the results, because a single number off a single run is really just noise wearing a suit. And here's the part I find most useful of all. The vote count tells you more than the verdict does. If it comes back 3 out of 3, I believe it. If it comes back 2 out of 3, I go and look at that one myself, because the judge has just quietly told me that this particular case is genuinely hard. The second thing is bigger, and honestly it took me a lot longer to accept. The first time my judge disagreed with me, I assumed that the judge was being dumb. But it wasn't being dumb at all. It was undefined. Nobody had ever told it what good actually meant, so it went ahead and made something up. And it made it up with complete confidence, which is the whole problem with these things in a single sentence. So here's the test I run now before I trust any judge at all. Let's say you take the same piece of work and you hand it to 2 people who genuinely know the subject, and you have them grade it cold, with no rubric and without talking to each other. Then you look at how often the 2 of them landed in the same place. That number is your ceiling. If 2 experts only agree with each other some of the time, then no model is going to beat that, and a model scoring somewhere around there isn't failing you at all. The task is just genuinely subjective, and you didn't know it yet. And every place where those 2 people disagreed is a place where your own definition of good is still vague. That isn't the model telling you it's broken. That's your rubric telling you. So before you ask whether your AI is any good at a task, ask the harder question first, which is whether 2 humans even agree on what good means here. Because your eval score is always partly a measurement of the model, and partly a measurement of how clearly you defined the thing you wanted in the first place. And with that, let's go ahead and build one. Plain Python, no frameworks, and the task is small on purpose. An AI that reads a support ticket and files it as billing, bug, or feature. We'll start with the cases. 10 tickets, each one with the label it should have been given. And take a look at that fourth one there. Somebody wrote in and said, "Great job." The app deleted all my data, which is sarcasm, and the model happily filed it away as a compliment. That's a real failure, and it is now permanently the most valuable line in this file. Every failure you find becomes a case, and it stays a case forever. So over time, your cases file turns into a kind of scar tissue for the system. Then comes the run, which is the boring part. One function that calls whatever model you happen to be using, and one line that collects an answer for every case. That's the entire run. And then the grader, and we start as cheap as we possibly can. 2 checks, and there's no AI anywhere in there. Is the answer even one of the 3 labels I allowed? And is it the right one? It runs in milliseconds, it costs nothing at all, and notice that both of those failures come back with a reason attached, not just a false. And finally, the scorecard. Let's run it. And there it is, the sarcasm one. That's an eval. 30 lines or so, and it tells you something that no amount of eyeballing ever will. But of course, most of what you actually care about can be checked with an if statement. Is the explanation clear? Is this faithful to the source? There's no equality check for any of that. So the gate has to be another AI, and now we're right back to the awkward part, because you've just hired a judge that has exactly the same disease as the defendant. It's going to sound every bit as sure of itself when it's wrong as when it's right. So let me show you how I build one that I can actually trust. We'll start with the prompt, and I'd like you to notice what's missing from it. 2 things here. First, it has to give me a reason, always, even when it passes, because a verdict that I can't interrogate is just another confident sentence from a machine that is confident about everything. And those reasons aren't decoration either, they're the data. When my judge and I disagree about something, the reason is the thing that tells me which one of us was actually wrong. Second, notice how little it knows. There's no context about my project in there, no explanation of what I was going for, and no hint about what I'm hoping to see. Your instinct is going to be to load that prompt up with all of it, and I'd really encourage you to resist that, because a judge that knows what you're hoping for turns into an accomplice. These models want to be helpful, so give it nothing to be helpful about. And now the part that cost me. Count the ways that fails closed. If the judge times out, that's a fail. If it writes prose instead of JSON, that's a fail. If it invents a verdict I never offered it, something like maybe, that's a fail. And if it hands me a verdict with an empty reason, that's a fail as well. I learned this one the hard way. My judge timed out once, and it didn't crash, it simply didn't come back. And the code around it did exactly what code does when something doesn't come back. It shrugged and it moved on. And the thing that never got looked at went straight through the gate anyway, and it looked exactly like everything that had genuinely passed. So the rule I follow now is that the absence of a pass is a fail, never a skip. That's about 4 lines of code, and they are worth writing. And then, because a single run lies, we ask more than once. We ask 3 times, and we take the vote, and that third return value matters more than the verdict does. 3 out of 3 is a pass that I believe. 2 out of 3 is a pass that I go and look at myself. So let's review what we've built. 10 real cases. Cheap checks first, then the judge, and then you. A gate that explains itself, that fails closed, that knows as little as possible, and that runs more than once. And underneath all of it, a definition of good that two humans could actually agree on, because that is your real ceiling and not the model. Do that, and the next time a new model comes out, you're not arguing about vibes on the internet. You run your 10 cases, and you know in about 4 minutes whether it's better for your work. You change a prompt, and you find out immediately what you broke, because you always break something. And I think it's better quietly turns into 9 out of 10, and here's the one that fails, and here's why. If this was useful to you, let me know in the comments what you're building evals for, because that's honestly where I learned the good stuff. Give the video a like if it helped, subscribe if you'd like more like this, and I'll see you in the next one.